Let us solve this example and exercise 7.4 in this lecture. So the first, that is this example, is number of ways of choosing 4 cards out of a pack of 52 playing cards. Okay, so what is the number of ways of choosing 4 cards out of 52? 52C4. And if you want the exact number, you can calculate it like this: 52 into 51 into 50 into 49 divided by 4 into 3 into 2 into 1, right? So this is the total number of ways of selecting 4 cards out of 52 playing cards. Now these are certain questions. First, 4 cards are of same suit. So 4 cards should be of same suit. Now how many suits are there? There are 4 suits. Okay, it may be clubs or spades, diamonds or hearts. I think these are the 4 suits. So, and all these have 13 cards each. Okay, so if 4 cards are going to be of the same suit, so I have 4 choices. Either I can choose 4 cards from this suit, or, so there is sense of or, so I'll add. I can choose 4 cards from this suit or this suit or this suit. So my answer is going to be 13C4 plus 13C4 plus 13C4 plus 13C4. These are the number of ways. I'll have to add these because I have option. I can choose from this suit, this suit, this suit, or this suit. Now in the next part, 4 cards belong to 4 different suits. So that means I need to choose 1 card from each suit. So I have to choose 1 card from this, and so I have to multiply 1 card from another suit and 1 card from another suit. I am emphasizing on this word and because I want you to multiply this time. So how many cards are chosen? 4 cards are chosen and 1 from each suit. So you have to multiply now. 4 cards are face cards. So how many face cards and how many numbered cards are there? If you see, there will be 12 face cards in total. 12 face cards, because in every suit I have got 3 face cards and 10 numbered cards, right? So in total 4 suits are there, so 3 into 4, 12 face cards will be there. So if 4 cards that I choose are face cards, so in how many ways can I choose these? 12C4. 12C4. Okay. Now in the next part, 2 are red cards and 2 are black cards. So you know 26 cards out of 52 playing cards are black and 26 are red cards. So I have to choose 2 red cards and 2 black cards. Fourth part, I have to choose 2 red cards and 2 black cards. So these are the number of ways of choosing 2 red cards and 2 black cards. Cards are of the same color, so either they will be black colored cards or they will be red colored cards. So there is sense of or now. Either they are of same color. So, okay, so they are either red cards or they are either black cards. Alright, so if you have to do these calculations, I want you to do these yourself. You just need to calculate 13C4 and multiply it with 4. So it will be 4 into 13C4. And this is what? This is 13 into 13 into 13 into 13. So 13 raised to power 4. 12C4 is what? 12 into 11 into 10 into 9 divided by 4 into 3 into 2 into 1. So I want you to do these calculations yourself. So the question I have is NC8 is equal to NC2 and I need to find NC2. So this can be equal to this only if n is equal to 8 plus 2. That is, this is equal to sum of this and this, because these are not equal. So their sum has to be equal to n. And you can write the reason also once more. I have just written this reason in the examples, that this can be equal if a is equal to b, or a plus b should be equal to n. So that is what I am doing here. So n is equal to 10, and I need to find 10c2. What is 10c2? 10 into 9 by 2 into 1. That is 5 into 9, 45. Okay. So let us do this second question. Now the first part is, this is 2nc3 and not 2 here. So this is misprinting here. So 2nc3 divided by nc3 is equal to 12 is to 1. So let me apply the formula, that is 2n factorial divided by 3 factorial into 2n minus 3 factorial here, divided by n factorial upon 3 factorial into n minus 3 factorial, and it is given equal to 12 by 1. So now I have applied the formula here. In the next, that is this second part, what I'll do is I'll write it directly as we wrote 7c2, like 2 steps in the numerator, then 2 into 1. So we will do that in second part, but for this part, let us see. Or if you notice, the second part and first part are same on the left hand side, so I don't have to do anything. Let us see how. So see, this 3 factorial can be cancelled, and the numerator, this is 2n minus 3 factorial, this is 2n factorial. So if I write 2n factorial as 2n into 2n minus 1 into 2n minus 2 into 2n minus 3 factorial, I can write it like this, divided by 2n minus 3 factorial, divided by, now this n factorial can be brought, this n minus 3 factorial is one of the factors of this. So let me see how. N into n minus 1 into n minus 2 into n minus 3 factorial. N can be written like this, so divided by n minus 3 factorial. So I can cancel these. Alright, and if you notice, I can cancel this n here, and out of this 2n minus 2 I can take 2 common and cancel this. So let us do that in next step. 12 by 1 is equal to, this n is cancelled, so I'll write 2 here, and I'll take 2 common from this. So this will be 2n minus 1 into n minus 1, and here I'll have n minus 1 into n minus 2. This n minus 1 is also cancelled. Now I'll just cross multiply. So this will give me 12n minus 24 on the left hand side, and on the right hand side this is 2 into 2, 4 into 2, 8n minus 4. So 12n minus 8n is 4n, 24 minus 4 is 20. So n is equal to 5, right? N is equal to 5. This is what I had to find in this question. Now see, when I had 12 by 1 on this side, and this side here, this expression can be used in this part also, because this is nothing but this expression, which is 4 into 2n minus 1 divided by n minus 2. But now it is not equal to 12 by 1, it is equal to 11 by 1. So let me see the result now. So I'll cross multiply. I'll have 8n minus 4 equals 11n minus 22. So 11n minus 8n will give me 3n, and 22 minus 4 will give me 18. Now n will be equal to 6. So for the second part, n is equal to 6. For the first part, it was 5. How many chords can be drawn through 21 points on a circle? So if you notice 21 points on a circle, I am talking about non-collinear points, right? This point, this point, this point, this point. Let us say this point is P, this point is Q, this point is R. So if I join P with Q, it will give me a chord, right? If I join any two of these points, it will give me a chord. If I join Q and R, it will give me another chord. So if I choose any 2 points, they will be connected by one chord. But it is about selecting these points or choosing these points, not arranging these points, because PQ and QP are not two different codes, right? PQ or QP is one code, that is this one. So I need to select 2 points out of these 21 points, and that will give me the number of codes, because corresponding to every 2 points I'll have a code. So this question is number of ways of choosing 2 points out of these 21 known collinear points. So this will be my answer, that is 21 into 20 divided by 2 into 1, so it is 210. Okay, 210 codes will be there. In how many ways can a team of 3 boys and 3 girls be selected from 5 boys and 4 girls? So you have to select 3 boys out of these 5 boys, so 5C 3 ways, and so you have to multiply 3 girls from 4 girls, so 4C 3. These are the number of ways of selecting a team. Okay, so it will be 5C3 is 5C2. Okay, so 5C2 is 5 into 4 by 2 into 1, and we already know, we have memorized also, that 5C2 is 10. Anyhow, I have written it here. So 4C3 is 4C1, that is 4. Okay, so this is 10 into 4, 40. So there are 40 ways we can select such a team. Find the number of ways of selecting 9 balls from 6 red, 5 white, 5 blue balls if each selection consists of 3 balls of each color. So we have to select 3 from this, 3 from here, 3 from here. So 6 C3, and I total I need 9 balls. So I need to select 3 from here and 3 from here. So I need to multiply these, 5C3 into 5C3. So what is 6C3? 6C3 is 6 into 5 into 4 by 3 into 2 into 1, that is 20. So this is 20 into, what is 5C3? 5C3 is 5C2, that is 10, right? We just calculated it. And 5C3 again, so it is again 10. So 2000 ways are there for selecting 9 balls out of these, and the selection consists of 3 balls of each color. Determine the number of 5 card combinations out of a deck of 52 cards if there is exactly one ace in each combination. So how many aces are there in a deck of cards? There are 4 aces, one of each suit, right? And 48 cards which are not aces, right? 48 remaining cards, 4 aces and 48 the rest of the cards. So we have to select 5 card combinations, and one ace, exactly one ace should be there in those combinations. So I have to select one ace from the 4 aces and 4 cards from these 48 cards. So these many combinations will be there. 4C1 will give me 4, and 48C4 is 48 into 47 into 46 into 45 divided by 4 into 3 into 2 into 1. So this will be cancelled, and this is 6. 8s are 48, right? Now what I'll do is I'll multiply 8 and 45, so it will give me 0, 360, and then I'll multiply it with 47 into 46. So let me see what it is. 42, 4, 28. Okay, and then 28 to 18. 2, 6, 11, 2162. Now I need to multiply 2162 with this, right? So I leave this multiplication to you. This calculation part you need to take care of yourself. Okay, all right, so I am not calculating this. In how many ways can one select a cricket team of 11 players from 17 players in which 5 players can bowl? So out of these 17 players, 5 are bowlers. Only these 5 can bowl, right? Rest of the, how many are remaining? 12 players. So these 12 cannot bowl. And each cricket team consists of 11 and it must include 4 bowlers. So I have to select 4 from here. So 5C4 and rest of the team from here. Rest of the team means 7 remaining players from this side. So 12C7. This is how I'll select this team. 5C4 into 12C7. So 5C4 is 5. 12C7 is 12C5. So I can calculate it like this. Okay, 5 into 2, 10. 4 into 3 is 12. Now 8 into 5 is 40. 9 into 11 is 99. 99 into 4 is 396 and then this 0. So these are the number of ways. A bag consists of 5 black, 6 red balls. Number of ways in which 2 black and 3 red balls can be selected. So there is AND. Okay. So I need to select 2 out of these 5. So 5C2 and 3 out of these 6. So 6C3. So this is calculation part. This is 10. 6C3 is 6, 5, 4, 3, 2, 1. So this can be cancelled. 5 into 4 is 20. 20 into 10 is 200. These questions are pretty simple. So the only challenging questions will be there in miscellaneous exercise, and that is the exercise you need to pay full attention to, because in your examination you will not get such simple questions. You will get certain difficulty level of questions. So you can expect a question from miscellaneous level of questions. In how many ways can a student choose a program of 5 courses if 9 courses are available? Total 9 are there. You have to choose 5 out of these, and 2 specific courses are compulsory for every student. So 2 courses are compulsory. You cannot choose these courses, right? So out of these 9, 2 are compulsory. So so out of remaining 7 courses, you have to choose 3 because these 2 are already compulsory, right? So 7C3 will be your answer. What is 7C3? 7 into 6 into 5 divided by 3 into 2 into 1. So this can be cancelled. That is 35. In 35 number of ways this can be done. Alright, so this was about this exercise. I hope you understood all the questions. Thank you.